So here is simple harmonic motion practice. What we're going to do is we're going to show you some examples of roll-off applications and see how we can model those situations using either sine or cosine. Okay, so there's some important stuff to look at when we're reading this problem. So Madison is jumping on a trampoline. As she jumps, her feet reach a minimum height of 2 feet above the ground. That's going to be important. All right, and a maximum height of 8 feet above the ground. All right, so that's going to tell us what our amplitude is and our starting and ending points for the peak, the maximum height and the minimum height. It takes 1.5 seconds for her feet to return to their starting position. That's going to tell us our period. All right, and then Madison begins timing her jumps. So it begins her jumps when her feet are at the minimum height. So that's going to tell us about what type of graph it is. So what we're going to do is we're going to make like a quick sketch of this graph and the situation. And that's going to help us figure out what to write down for our equation. Okay. So she starts off at a minimum of 2 feet and a maximum of 8. So if we start this graph off, it's going to go starting from the bottom, goes to the top, and then goes back down to the bottom. So this looks like a cosine graph, and it is because it's starting either at the top of the bottom, left or right, not in the middle. Okay, that is a cosine. If it was starting in the middle of her jump, then it would be a sine function. Okay, because it's upside down, it's going to be negative. All right, and then we've got to find the amplitude. That's why I left that little space between the negative and the cosine. The amplitude is take the difference between the max and the min, so 8 and 2, and divide it in half. So that's going to give us 3. So 8 minus 2 is 6, and 6 divided by 2 is 3. So that's what our amplitude is going to be. All right, next, let's figure out what the period is. So the period is 1.5 seconds, but a period for a normal cosine graph is 2 pi. So we're going to do this. We're going to do 2 pi. This was shown you in the notes yesterday. And then we're going to divide it by n, and it's going to equal what our period is going to be, 1.5 seconds. Okay, so we have to solve this equation. So we're going to multiply n to both sides and then divide 2 pi by 1.5. All right, and that's going to give us n is equal to 4 pi over 3. Okay, if we find it as a fraction. So that's what our number is going to be multiplied by our x term, 4 pi over 3 x. Okay, so if we take that number, 4 pi over 3, and set it equal to 2 pi, or 4 pi over 3x and set it equal to 2 pi, it will give us 1.5 when we divide it, which is what our period is going to be, 1.5. Okay. Now the last thing we have to figure out is there seems to be some kind of vertical shift. Okay. So how does our graph begin at positive 2? Okay. Well, if you remember from earlier when we did unit 3, cosine starts at 1, so we have negative 3 times 1 plus something, and that has to equal 2. So what's negative 3 plus something equaling 2 going to be? Well, if we add 5 to this, that will give us the starting point of 2, and that becomes our equation. Okay? Actually, I should put down another thing. Y equals. There we go. All right, number 2, Spider-Man. So Spider-Man is swinging back and forth in his web. He swings 20 feet to the left and 20 feet to the right of his center. Okay, so if you think about that, there we go, he's swinging. He starts at the center and swings to the right first. So he's starting here. He goes this way, 20 feet. Then he swings back this way. Then he swings this way, 20 more feet to the middle. So if we look at it that way, we can start kind of drawing our graph. All right. Since he's starting in the center, it's going to be a sine function, and he's starting going to the right first, so that's going to be positive. Okay, so that's what your graph should look like. Okay, it takes him 6 seconds to swing right, left, and then back to the center. That's going to be our period, so 6. All right, and then our max is going to be 20. Our min is going to be negative 20. Okay, and now we write down our equation. So if y equals, since it was sine and positive, with 20 as our amplitude, okay, then we have to figure out what the period is going to be. So we have 2 pi over n is equal to 6 multiply by n and then divide 2 pi by 6, and you get pi over 3. We're going to put pi over 3 in times x. Now there is no vertical shift because our sine graph is starting at 0, and then we're done. All right, number 3. A fish is swimming back and forth in his tank. So this fish tank is 120 centimeters long, and there's an underwater castle directly in the middle. So if the fish begins to swim at the castle's in the middle. Okay, so the fish swims to the left first. So if the whole tank is 120 meters, from the center to the outside is going to only be 60. And it swims back to the center, and then to the far right, which is again, and then back to the center, which is again 60. Okay, so we can kind of start drawing our graph, which then leads to our equation. So if he's starting in the center, but then he goes left first, it means he's going to go down, then up, and back to the middle. Okay, we have 60 here and negative 60 here. So he's swimming to the left first, which means it's negative. All right, and then his period is going to be how long it takes him to swim the whole thing, which is 1 minute. Okay, so it's a sine function. The amplitude is 60, and it's negative because we're going to the left first. Okay, then we have to figure out what the multiplier on the x is going to be. So we have 2 pi divided by n is equal to 1 minute. So if we divide that, n will equal 2 pi. So we're going to put 2 pi times x. Again, because it's a sine function, there is no vertical shifting. We're going to leave it just the way it is. And there's your equation for the fish. Okay. Lastly, we have number 4. Mark Twain sat on the deck of a riverboat. As the paddle wheel turned, a point on the paddle blade moved in such a way that its distance d from the water's surface was a sinusoidal function of time. That's just a fancy way of saying it's a periodic function, so it's a simple harmonic motion. When a stopwatch read 0 seconds, the point was at its highest, 16 feet above the water's surface. The wheel's diameter was 18 feet, and it completed a revolution every 10 seconds. So, let's draw this out. Okay, and as we go along, we can start filling in some important information. Okay, so one thing we can tell is the revolution was 10 seconds, so our period's going to be 10. Okay, the highest point above the water surface was 16 feet. Okay, but it doesn't tell us what the lowest point is, but it kind of gives us a clue. If it's 16 feet above, but the wheel diameter was 18 feet, that means there's 2 feet below the surface of the water. Okay, now it says it started at the highest point. So if it starts at the highest point at 16 feet, that means it's going to be a cosine function. It's going to go down. Oops, that was ugly. It's going to go down and back up. Okay, so that's what we're going to try and graph. All right. If you do the distance between 16 and negative 2, it's going to be 18 total. Okay. And then 18 divided by 2, it's going to be 9. So our our amplitude is going to be 9. There's your cosine. It's a positive because it starts up top. Okay. And then we got to figure out the period. So we have 2 pi divided by n is equal to the period is going to be 10 seconds. So we multiply by n and then divide 2 pi by 10, which gives us pi over 5. So we put pi over 5 right here, times x. Now, the other thing that's so weird about this question, though, is if our graph is starting at 16, our amplitude is only 9. So if we did 9 times 1 plus what number gives us 16? And the answer to that is 7. Okay, so 9 times 1 plus 7 gives us 16, and that puts the starting point at 16. Okay, So now usually you'll see that the cosine functions a lot of times might need a extra vertical shift, and the sine functions generally do not. Okay. Alrighty. And that's it. So hopefully you tried this out, had some luck. If you didn't, that's okay. That's what the key is for, to help you along. Tomorrow we'll do the same kind of thing. I'll give you another sheet to practice these on, and then give you another key. And then next week we're going to have the beginning of our project. All right, good luck.